Hello everyone, welcome back to Scalar Academy YouTube channel. Myself Vamsi. In this tutorial we will be solving another most frequently asked dynamic programming question in an interview named coin change. So we will be discussing two solutions. One is a recursion, another one the recursion solution by using the dynamic programming memoization technique. Okay. So without wasting any time, let's get started. So before starting, so if you are visiting channel for the first time, please don't forget to subscribe. So if you like this content, please hit that like button up, and if please let us know what do you feel about this video in the comment section. Thanks. First, let us understand the problem statement. Okay. So you will be given an array, and it contains a coins. Let's say what are it will be 1 comma 2 comma 3 sorry 5. Okay, so these are all the coins, and they will give you the target value and integer. Let's say in this case it will be 11. So you need to figure out what will be the minimum number of coins to make this target value. Let's say so you went to a shop, okay, and you gave 2000 rupees and you asked for change. Okay, so now, so if a shopkeeper has given all the 10 rupees coins, like 10 rupees notes currency, okay, so 10 rupees into 200, so you will get 200 rupees are notes. Okay, 200 notes, like you can say coins. Okay, 200 coins. Now if shopkeeper has given you 100 rupee coins, then it will require 20 coins. 20. If shopkeeper has given you a 500 rupees coins, and it will be taking 4, so here 4 coins. So basically there is no 200 and I'm sorry, 150 rupees 500 coins, but I'm saying that. Okay, and if like you have given 2000 rupees note, again he gave you 2000 rupees note. Okay, then it require only one coin, right? One coin. So this is what a minimal number of coins, okay, you will get. Okay, so this could be your answer. This is your answer. So a minimum coins, okay, for a given currency. Okay, so let's try to understand for this particular example. Okay, so first, okay, so there are 1 rupee coins, 2 rupee coins, and 5 rupee coins. Okay, and here one thing to understand here is very important. So whenever you are in an interview, you have to ask one question at the first. What is that question? So are these coins are infinite supply? Means infinite supply. Like, so can I get these 1 rupee coins as many times I want? So let's say here, to make 11 rupees a change, you required if you have given 11 1 rupee coins, then it will be 11 rupees. Target sum achieved. Okay, so no, I don't want like that. Okay, so what I will do, I will make 1 into 9 rupees. Okay, like I will give a 9 coins of 1 rupees, then 1 2 rupees coin. Okay, then what happens? It will again 11. Target sum achieved. Okay, so in this case totally we have given 11 coins. Now I am counting 11 coins. Now here 9 1 rupee coins and 1 2 rupee coin, so totally 10 coins. So it's great, right? So I will try 2 rupee coins now. Okay, so 2 into 5 are 10 and 1 1 rupee coin. So here 10 and 1, it's 11. So how many coins I have taken now? 5 plus 1, so it's a 6 coins. Less than 11 and 10, right? Yes, it's acceptable. Now is there any other way? Let's see. Okay, um, so still with the 1 and 2 combinations you will be having more coins as well. So like 3 2 rupees coins and 5 1 rupee coins, something like that as well. Okay, and here, yeah, so now let's come to 5 rupees. So can I say 2 5 rupee coins plus 1 rupee coin? Totally I have 3 coins now, which is way more better than other solutions, other coins, right? Since I am wanted a minimum number of coins required to get target value. Okay, now so is there any other way that we can reduce this further? Let's keep on trying. Okay, so 1 5 rupee coin and a 2 rupee coin, and so 5 4, so 1 into 2, or you can say 2 into 1 as well. Okay, so it will become 4 coins. So I can say that 3 is the minimum coins I required to make this 11 rupees. So this is what an answer looks like. Okay, so this is the answer if there is an infinite supply of coins. Infinite supply of coins. What if there is only one coin is supplying to you at a time? Okay, so let's see the given coins are 1 2 and 5, and you two required to make 11. It's not required. It's quite greater. So if you add all these as well, you will get only 8 rupees. It's not 11 rupees, right? So you can't make at the change of 11 rupees. So how can you do? Let's say if I have given you a 6 rupees, like you need to make change for 6 rupees. Now how many minimum coins you require? So if you consider all the 1 coins, then 1 into 6 6 coins. If you required a 3, then 3 coins. 5 into 1 plus 1 into 1 are 2 coins. So this is, can I say at max you require 2 coins if I am giving a finite and I am searching for target 6. Okay, so but in this like tutorial I will be discussing infinite supply of coins. Okay, so I'm pretty much sure that after finishing this entire tutorial, watching this entire tutorial, you will be able to solve this limited number of coins supply on your own. Okay, just give it a try. Okay, we catch up with another tutorial where I will be explaining with limited number of coins as well. Okay, now I hope you have understood the problem statement clearly. So now I recommend you to please pause the video, think for a while. Okay, so I will give you a hint as well. Okay, so think in a recursive manner. Recursive manner. Okay, just think in recursive manner. So let's start. Okay, so I'm following a top-down approach. Top-down approach means where I will be starting from last index and moving towards the starting index. Means if I have array of size like coins of size 10, I will be starting at 10th element, and I will move keep on moving till the last element. Okay, first element, sorry. Okay, that's how top down approach of recursive works. Okay, so now let's see. So let's stick to the example that we have now. So the array, the coins are 2 1 2 5, and the target value is 11. Okay, so let me point out the indexes 0 1 2. So what is the last index? The last index is 2. So I will be starting from a second index. So here I'm considering parameters or my index and a target value. Okay, let's say I will be having a function called a coin change. let's name this as a CC for our simplicity, and I will be starting at 2 and I am searching for 11. Okay, this is what my initial state looks like. Now tell me, so I'm currently here. What is the decision can I make here? So can I say uh if okay, so 5 is less than 11. Yes, hota, like happens, right? So 5 is less than 11. So can I say, after seeing this particular thing, can I assume that to make the change of 11 I can have 5 in that thing? So secondary is like forget about rest of the elements, just think about this 5. So can I include a 5 in my 11 coins? Yes, I can, right? So 5 is less than 11, so I must can include that. Okay, so I can include that. So CC, and so my current sum will be going to be a 6, right? So I'm searching for 11 initially and I have included a 5 in it. Okay, and I have reduced that target sum to the 6 now, because I have reduced that 11 minus 6. Okay, done. Now tell me, so I can take that if I don't wish to take that. So I'm not interested in taking that a 5. Yes, right? So that's my choice. Okay, so let's assume you are a shopkeeper and you have all the 1 coins here, 2 coins here, and 5 coins here, like infinite, and we have to give the change of 11 rupees. So it's your take whether you can take this 5. So yeah, I wanted to give only 1 rupee coins to the guy. So I can so that's a decision of shopkeeper. Okay, so he can give 2 rupees, he can give 5 rupees, he can give 1 rupee as well, but at the end of the day it is his choice. Okay, so that is what we have to stick. Okay, so here this is called a take, this is called not take. Okay, so take means you are considering that particular value into your change, and not take means you are not including your that particular value into your sum. Okay, now so if you have included this, okay, you have included this particular 5 into your target sum. Now tell me, so since it's an infinite set of you have infinite coins. Okay, so here you will be having all the coins. Okay, all like 1000 infinite coins. So if I am making it a choice of, like, if I wanted the change of 10, I can give all the 5, right? All the 5, 2 5s, that is possible, right? So in that case, though, if you have considered that particular value, you can again consider that value. So here, do I need to move to my next index? No, I can stay there only, and again I can check whether that particular value is again included after including one time, and again I will check whether that can be included or not. Okay, so I will stay in that second index only. Now this is the case of if I take. If I not take, I don't wish to take this 5. Okay, then my target will be 11, and so if I'm not interested to take this 5, I can move to next index, right? So I will make my index as 1. Oh, I hope you guys have understood. Okay, let me tell you. So here what I am doing, so if let's say coins of index less than target. Okay, so less than target. So if this is the case, what I'm doing, okay, if this is the case, what I'm doing, so either I can take or not take. Okay, if I'm taking this, I'm doing this, like I'm my subtracting that particular coin from my target sum, and I am again staying back there only, because I have to make the I have to include. I don't know whether again that value can be included or not. Okay, and if I don't wish to take that kind, I can simply just move on. Okay, so my target sum will be target sum only. Okay, so here if I consider that if you take that particular coin, what do you need to do? You need to increase your coins, right? So I will simply return 1 plus. Okay, if you wish to take that coin, you have to increase one value. So समझ हो गया. Now let's go. So again you are standing that particular thing. So now second index and you have a target of 6. So 5 is less than 6. Yes. So again what you can do, you can take that value. So 2, and if I take that, I am standing there itself and I am making the sum as 1 now. And if I don't wish to take that, so it will be 1 and 6. Now again, so I'm standing at second index and I'm aiming for target 1 now. So 5 greater than 1, right? So I want the change for 1 rupee and you are showing me 5 rupees. That is not sufficient, like it's exceeded, right? So you must not include that. So what you will do? So can I say, so if 5 is not included, there are some other coins which might include, right? So what I can do, I can simply, I won't take that, okay, I won't take that. I can just move to another indexes, okay, which is a CC of 1. So at 2's next 1 and again target of 1. Yes, here I have only one choice. Okay, I wish not to take that. That's it. Okay, now I'm standing at one index and I'm searching for one value. Yes, 2 greater than 1. So I may not include that. I have only one choice here. Now again what I could do, 0, 1. So I'm standing at 1 rupee coin and I'm searching for 1 rupee target sum. Is that the fine? Yes, I can include. So which is a less than or equal to. So I can include. So 1 plus. So I have taken that. Okay, I have taken that 0, 0, right? And if I don't wish to take that, CC of -1 and my sum will be -1 only. Okay, so now tell me, my target sum became my target coin will become a 0. So I got it means that I got the change for what I'm looking for. It means that I got the change what I'm looking for. So I will simply return 0 here. Okay, will simply return a 0 here. So you have written 0 and 1 plus 0, it's a 1. So you will return 1 here. You will return a 1 here. Now you have seen a negative index. Okay, since you have seen a negative index, what you need to do? Okay, so basically since you are you want a minimum number of coins, so you can return something a max value like int max or 1e9. so if you are returning 1e9, it might get overflow, so just do -1. It will, oh yeah, like that happens. Okay, now you will consider minimum of these both, right? So minimum of these both and you will return 1. So 1, and here you will return, so you have only one option. Okay, so you will return 1, okay, to this thing. Now 1 plus 1, it's a 2. 1 plus 1, it's a 2, and you will go up, so it will return 2. So from left side, okay, you got 3, right? So 1 plus, sorry, from left side you got 2. Okay, from left side you got 2. Let's see here. And you are currently standing at this particular 1th index and you want the sum of 6. So 2 less than 6. Yes, so it means that you can take that guy, CC of 1, 4. Or you might not, you are not interested in that thing, so you will just move down and you will keep that sum as it is. Now again you are standing at here. Since you have considered this, you have to make +1. Okay, now you came here and again, so you are standing at 1 and you want the sum of 2, sorry, 4. So 2 less than 4, again you can consider that 1 plus cc 1 comma 2, and it's your decision, you are not interested in that, so 0 comma 4. So again you came to left side and you will solve this, and you are currently standing at 1th index, means at second coin, and you want the target of 2. So again it's a less than or equal to, it's an valid thing. So 1 plus cc and 1 comma 0, and here your sum target sum became 0, so you will return a 0 here. 1 plus 0, it's a 1, so you will return 1 here. So 1 plus 1, it's a 2, so you will return 2 here. 1 plus 2, it's a 3, so you will return 3 here from a left side. Okay. Okay, so did I forgot something here? So it's your wish as well, like here. Okay, so if you wish not to take this, it will be 0 comma 2. Okay, so if you are standing at 1, okay, so if you are standing at 1, if you consider this, and you can take up that, so cc of 0 comma 1, and if you wish not to take cc of 0 comma minus 1 comma 2, okay, so it will return int max, since you have reached negative index. Okay, and again you will go here, and you can again consider that cc of 0 comma 0. Okay, so it will, since you have reached a 0, it will return int 0, and 1 plus 0, it's a 0, so 1 plus 0, it's a 1, it will return 1, and 1 plus 1, it will become 2. Yep, so minimum of these two, it's a 2, so minimum of this 1 comma 2, it's a 1, so you will return 1 plus 1, so it will be 2. And so you need to solve this. Let's say you so you are currently standing at second index, 0th index, and you wish to solve this as a 4. Okay, so means that you have 5. Okay, so you have a 1 rupee coin, currently you are at 1 rupee coin, and you want to make the change of 4 rupee. So that is possible, right? That is possible. So you will say cc of 1 plus 0 comma 3, and if you wish not to take that, it will be cc of minus 1 comma 3 4, so it will return int max. So you will go this thing, cc of a 0 comma 2, so 1 plus, so again it will, if you wish not to take this, cc of minus 1 comma 2, so if you wish to carry on, and 0 comma 1, and you are currently standing at 1 rupee coin, and you want a 1 rupee change, and so again if you wish not to take this, and it will return minus 1 comma 1, so it will return int max. Here it will return int max, and you will go again, so here again you can stand at 1 plus cc of 0 0, and you wish not to take up this, and minus 1 comma 0, so it will return int max, it will return 1. So since we have reached some 0, it will return 0, so 1 plus 0, it's a 1, so it will return 1. So 1 plus 1, it will be 2, so it will return 2. So again it's a max and all, so it will be a 1 plus 2, it's a 3. So yeah, so int max of 3, a minimum of 3 comma int max, so it will be 3, so 1 plus 3, it's a 4. So here 4. Okay, so 2 comma 4, it's a 2. Okay, minimum is 2, so here 1 plus 2, it's a 3. Okay, so again you need to traverse on this side, so I'm not making this. Okay, so it's already a mess. Okay, you can, I hope you have figured out what is happening here. Okay, So give it a shot, okay, you will get to know. So we are doing only three rules, okay. I will let me summarize those things, okay. So before moving on, let's assume it has something written, and again minimum will be 3 only. We know that answer is 3. So anything, so I'm pretty much sure that nothing was less than 3, so I will return simply 3 here. And here I got a 2, okay. So 2 is minimum, so 1 plus 2, it's a 3, so it will return 3. So not take, if you go on carry on this, anyway you will get 3 as minimum, so it will return 3 as your answer. So this is how it looks like, okay. So a big tree, okay, because you will be having a lot of combinations here. That's why, because you will be having infinite supply of coins, right? That is the reason why you have this big recurrence tree, okay. So let's go and try to code this up, okay. Let me summarize what we have did so far, okay. So basically we have a function called a coin change, where we will be having a index, and a coins means it's an array or a vector, and this is an integer, and you will be having an target value, okay. Again it's an integer. Now you will be entering into this particular function, and first, so what will be our base case? Figuring out the base cases. First thing, sigma rule in recursion, okay. So base cases. So can I say my first base case would be, what if my target equal to 0? What if my target equal to 0? Can I say simply return 0, because I don't require any coins, right? So to make the sum of 0, target of 0, you don't require any coins. That's a simple one base case. And next, so what if, so since I'm starting my index at the max thing, so what I can reach, so till I can reach index less than 0. So whenever my index less than 0, it means that I have reached a negative index. So can I say whenever I have seen a negative index, I can simply return int max. So because I'm aiming for minimum answer, so I'm returning int max. So anyhow it will be going to be and not in my answer. Cool. And yeah, these are all the two base cases, okay, base cases. Now our actual logic comes here. Now first thing, so it has passed this both. Now what you need to check? So you need to first check the coin which you're currently standing is less than the target or not. Means, let's say you have a currently a coin of 5 rupees and you want the sum of a 4, okay, your target is 4. Now obviously you can't include 5 in that particular answer, right, target, right, to make that target, right? So what you can do, so let's say whenever coins of that particular index greater than target greater than target, then you can't include that coin. So simply what you need to do, you just need to go to another coin. So simply return coin change index minus 1 coins amount. That's it. So what if this is false? Okay, so coins is less than target, less than or equal to target as well. Then what you need to do, you need to include that in your answer. That is one choice, okay. So it is less than, okay. Now means like you are currently standing at 2 and you want the sum of 4, target of 4. So it is possible. Now it's your choice to whether to take that answer in to take that 2 coin into your 4 or not to take that coin into your 4. Okay, so let's say I will have two variables. Okay, two variables. Let's say int take. Okay, so if I take that coin, I must need to keep track of that, right? So 1 plus, I just need to increase my coins. So 1 plus coin change, coin change. If I include that, if I include that coin, now what I need to do? So since I have infinite supply of coins, I need to keep stay there itself. That is what we have seen in recursive, right? So I will be staying there. I'm not increasing or decreasing my index. I'm staying there only, and my coins are coins. Like so, whatever I got the coins, I will be supplying that. And so if I consider that into my answer, means a target, I just need to make that target minus coins of index. Agree? So if I include that, I have to remove that from my target, right? Then only I can make it that to a 0. So our agenda is to make that target equal to 0, and whenever we have assumed a target is 0, our job is done. We have found the choice, change. Okay, this is for take. So what if I wish not to take? Not take. Then what I need to do? So I don't need to increase my coins. So I will simply call coin change. If I wish not to take that particular coin, I have to go to next coin. So index minus 1 coins target. I'm not taking my I'm not considering that particular coin. That is the reason why I'm not minus doing subtraction that particular coin from my target. So after making these two recursive calls, what I need to do? I need to simply return minimum of take comma not take. Agree? Done. 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 So yeah, so did we figure out all the cases? Did we figure out all the cases? No, I don't think no. Why? So let's say uh, if you are in an interview, you have to ask this question in the beginning. Okay, so let's say I am my target is 1000. Let's assume 1000, and I have given you coins of uh, coins of 0 1 1. Okay, let's assume 1, or let's say okay, so let's change this. Okay, so I have given you a target of 3 rupees. Okay, target of 3 rupees, and I have given you these coins of 2 rupees. I've given you only 2 rupee coins, and you need to make the target of 3 rupees. Now is that a possible? No, that is not a possible, right? So if you take 2 rupees coin, it will be minus 1. Okay, still you need a 1 rupee coin, and if you take a 2 rupee coins, you have like you are giving 4 rupee change, not 3 rupees. Okay, so as a shopkeeper I am getting lost. Okay, so I am not, yeah, I am not interested in that case. Okay, so in that case our answer will return int max. Okay, so int max, it will return int max. So okay, so it's your interviewer choice what to return. Okay, so whether he wanted to return something like not possible or something. Okay, it's interview choice, but mostly they will say return minus 1. Okay, if there is no particular answer, you can't make the choice for the, like you can't make the change for the given target, just return minus 1. Okay, so in this scenario I will return a minus 1 in my like main function. Okay, so now that's it for the code. Okay, so let's quickly go and write the code for this particular approach. Now let's try to code the approach what we have discussed so far. Okay, So the input format for this particular thing would be you will be given a first n, okay, and you will be given then target, then you will be given set of coins, okay. So it means n, target, and a vector, okay. Now let's try to accept that input. So int n and target, and you require a vector of this size, let's say coins of the size n, okay, and you need to accept them. N coins of yeah, that works. So till now we have accepted the input. Now we need to process our answer. So let's assume we have a function called coin change, and it is accepting index, coins, and target. So here we are passing index as n minus 1, then coins, and then a target. Okay. Now let's go and code this particular a function. Okay, int a coin change of let's say index, and then we are passing a vector as int coins, and then int target. Okay. First our base cases. So first base case is whenever our target is equal to 0, simply we are returning 0. Okay, so whenever our target is 0, we are simply returning 0. So if our index are less than 0, so index less than 0 means, and we have seen a negative index, then what we need to do? So as we have discussed, we are returning an maximum value. Okay, so here the maximum, so I'm not considering int max, let's say at 10 power 9. Okay, so if we return 10 power 9, in some cases it might get into the overflow. Okay, so you can do -1 simply. Okay. Now this is our base cases. Now what is the first case? So what if our current coin is smaller, large, greater than what, greater than your target. So if it is greater than your target, you must not include that. Instead you have to go to another coins, okay, other coins. So if coins of index greater than at the target value, then simply return coin change. You have to go to the next index, means you are currently at index, and then if you have to go to the next index, then it will be -1. Then it is a coins, then it is a target. So you are not including that value, so that is why you are keeping the target as it is. So if this is not the case, means it's a less than, so it's like current coin is less than target. So if it is less than target, it means that you can include that or you can not include that. That's your choice. So let's say int take. Okay, I can take that value or I cannot take that value. Okay, that's depends upon the choice. So if I include that value, okay, let's say I have decided to take that coin. So then what I need to do? So I have to include that. I have to increase my count, right? So coin change. And again, do I need to go back to the next element or do I need to stay back here itself? I need to stay back here itself. Why? So I have infinite set of coins, right? So though if I consider that particular coin for the target, I have to check again whether I can make another coin of this particular target coin this as well. So that is why I will stay at this particular index only. Then coins. Now what I need to do? So I have taken that coin. Okay, I have taken that coin. If I have taken that coin, what do I need to do? If I have taken that coin, what do I need to do? I need to include, I have to decrease that particular coin is that particular coin. Done. So if I have decided not to take up that coin now, not taken. So now what happens? So I may not increase my coin value since I have not taken that. Instead, I have to go to the next index, right? So if I decide not to take current value, then I have to go to the next value. Then coin. Since I have not taken that value, my target will be as it is. Now at the end, what I need to do? I need to return minimum of taken and not taken. So this is what a algorithm looks like. Okay, so I'm hoping this would return our answer. Okay, now so we are getting our answer in answer variable, and so here we need to uh, make a corner case where we will be returning, like where we will be not having enough coins to make the current change. Okay, so then what it will return, our algorithm will return 1 e 10 power 9 minus 1. Okay, so if answer not equal to 10 e power 9 minus 1, so it means that there is some suitable guy. Okay, so I can make the change. So in that case I can print this answer only. So if not, if my current answer is 10 power 9 minus 1, then I can simply print a minus 1. Done. So yeah, yep. So let's so for this input I'm expecting output as a 3. Let's try to run this code first and then we'll see. Since it's recursive and the complexity of this approach would be exponential, it is taking a lot of time. Okay, so it given 3. Okay, let's check out for failure, like where it will be not making not have the enough coins to make the change. So I have a array size of 1 and I'm looking for 3, and the current values I have is 2. Okay, now save this and let's build this solution. It will return answer very quickly this time, I guess. Yeah, so we got -1. So why it has written answer very quick? Because so we have very less number of cases to check for. So yeah, that is what a time complexity means, why time complexity is so much important in our life. So yeah, so it is returning correct answer. Now let's try to analyze the time complexities of this particular approach. Yeah, so it is definitely going to be exponential. Okay, so how exponential? So I'm making a 2 function calls here. Okay, so it is at at max, in worst case I'm making 2 function calls. Okay, then it will be 2 power something. So what is that something here? So can I say what are all my changing factors here? So target and index and target. So can I say I'm finding all the possibilities of an current index and the target. So in that case, in worst case, it would be index into target. But if we have here infinite set of coins, since we have infinite set of coins, the time complexity of this particular approach would be greater than 2 power index into target, because we have infinite set of coins. Since you have seen that recursive tree as well, it has a lot of recurrences. Okay, it has a lot of recurrences. Okay, I have stopped at the middle, but it has a lot. Okay, so yeah, if you are in an interviewer then straight away ask you to optimize this particular solution. So how to optimize this? So what you can see here, so I can see I am repeatedly solving the problem which I have solved previously. Doesn't make sense? Yeah, it makes sense, right? So let's see. So let's figure out something. So here cc of 0 comma 1, and again I am solving cc of 0 comma 1 here, and again I am solving cc of 0 comma 1, again I am solving cc. So it's repeated, like repeated, right? So 1 comma 4 again, and so yeah, 0 comma 0 everywhere, 0 comma 0, and again I will be having 0 comma 0, 0 comma 0. Okay, so I'm solving the same problem again and again. So can I say it as optimal substructure sub problems? So so whenever there is some cases where I will be doing same task repeatedly, like same task more than one time, in that case I can say memorize. I can memorize the answer. So memorizing answers can be comes under dynamic programming. Okay. So how can you convert this particular logic into the dynamic programming? So basically, let's say, so first you need to figure out what are all the changing factors here. So index and target are the changing factors here. Index and target. So you have to uh, create a 2D matrix with the size of index into target. Okay. So let's say simply a vector of a vector int dp n into vector of int target. Initially let's assume I'm initially filling it with -1. Okay, now so what I can do, I can pass this dp here. Okay, I can pass this dp here, and whenever I am returning my answer, so not simply returning the answer, so before returning answer to my main function, I can say store that in my state, dp state. So what will be my dp state? So dp of index of target. So I will store that answer into this particular state. So that is how I will do. So wherever I am making recursive calls, I will do that. So here again I am considering the answer. So in dp of int and target equal to min of take comma not take. So here before entering into this logic, like right after the base cases, I will include a check here whether I have solved that particular combination, like so 0 comma 0 cases, like in where index is 0 and target I am searching for is 0. So such cases. So whenever I will check here. Okay, so like dp of index of target, so not equal to -1. So if that index, like that particular state has not doesn't have -1, it means that it has some value, it has already computed. So what I will do, I will simply return that answer. So dp of target, done. Yes, this works. This is what a memoization means. Okay, so memoization means you will be having your recurrence code, and you will be simply just converting that code to dynamic programming by simply adding your dp states over there. Okay, so let's go and code this particular solution. So we are not writing code from the scratch, so we will be just doing some modifications here only. So the first modification here is you need to create an two-dimensional vector dp of size n into size of target. So I'm filling it with -1s. Okay, and I need to pass this as my argument. Then if I'm passing as my argument, I have to catch that in my parameter as well. Yeah, so wherever I'm making call, I need to update the as always. So here dp, here dp. So whenever I am returning something, so before returning I just have to store that in my states, db states. So dp of index of a target. Okay, so then yeah, so I need to check here. So check for previously solved current state. So if a dp of index of current target not equal to -1 means that simply return that answer. Yeah. Do we need to forgot anything? No. Okay, so let's save this, and so let's try to change our inputs. So 3, 11 and 1 to 5. So I'm expecting 3 as my answer. Okay, so we got something bigger here. We got something bigger. Uh, 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 yeah, so here. So yeah, we need to include a target plus 1. Why? So if we are searching for target 11, so we have to assign the space of we have to assign the states until 11, right? So if we want till 11, we need to give the array size as 12. So that is the some silly mistake I did. Let's try to run this code again. Yeah, done. So we got this output, and yeah, so it works fine, I guess. So give it a try. Okay. Um, yeah, now let's try to analyze the time complexity of this particular approach. So basically, if you are in an interview, if you come till so far, it's fine, because I have seen this problem in a couple of platforms as well. The cases were are not that much bigger, like maximum, like target will be maximum of 12, and the end will be maximum of 10. Sorry, not 10,000. Okay, it's a 10 power 3 or 10 power 4 at max. Okay, this particular dp solution. Okay, so the time complexity of this particular approach would be okay, it would be like n into target. Okay, and space complexities, since we have written memoization code, it will be taking extra stack space. Okay, plus we have taken the 2D dimensional vector, two-dimensional vector with the size of n into a target. Okay, so that is the overall complexity of that particular approach. So that's all for this video. Okay, let's catch up in the again next video. Bye bye.